spectrum. All objects release or emit electromagnetic energy. Anything that basically has some sort of temperature emits electromagnetic energy. You right now, your body temperature is around 98, 99 degrees Fahrenheit. You're emitting electromagnetic energy. Everything emits electromagnetic energy unless its temperature is absolute zero, which is negative 459 degrees Fahrenheit or negative 273 degrees Celsius. Our sun emits all forms of electromagnetic energy, geared towards really three specific that we'll go into, but it does release a little bit of some on the others. But as a whole, that full range of energy is the electromagnetic spectrum. Okay, the electromagnetic spectrum basically travels in waves. The wavelength is extremely important from crest to here to crest right here, is extremely important in determining the type of electromagnetic energy that it is. So from crest to crest, or we can even say from trough to trough, which would be here to here, okay, is used to tell us or distinguish the different types of electromagnetic energy. Okay, the electromagnetic spectrum, the entire range, goes from gamma to radio waves. So from gamma to radio waves. Short wavelength equals high energy. Long wavelengths equals low energy. Okay, we'll get back to this in a moment. The electromagnetic spectrum is also found in our Earth Science reference table. And here it is. If we could look at this one, and we'll get to the one in the reference table in a moment. It's very basic. Shows the wavelength in centimeters. Okay, so if we go to gamma rays, notice it's got 10 to the negative 11th centimeters in size from crest to crest. So this is extremely small wavelength on this side. That's a little symbol for wavelength. Versus over here, 10 to the third for radio waves. So that's large or long wavelength right here. Okay, if we go to our reference table, page 14, next page, we can see here our electromagnetic spectrum. Okay, decreasing wavelength, they're small all the way on the left here. And notice we got gamma rays, X-rays, ultraviolet, all small wavelength, versus long wavelength over here towards radio waves. They definitely made a change from, I think it was like prior to the 2011 edition, where they made you, they actually had the wavelengths in centimeters, much like the one we just seen. Here they don't have it anymore. It's not really, for some reason, New York State Regents doesn't require us to know that anymore. But they still need to know us whether we have small or long wavelengths. And we can see it here on page 14. Okay, here's our electromagnetic spectrum again. And you can see here, blown up a little bit, is this portion. Our visible light portion. Our visible light portion falls in right here between ultraviolet rays and infrared rays, or infrared energy. Okay, wavelength in nanometers right here, and you can see that these are the colors of the rainbow. The visible light portion is pretty important to us here on Earth. It allows us to see what we everything that you can see. Okay, some uses of radiation. We have gamma rays, X-rays, which people commonly use when you go to the dentist or you break an arm or you need to get checked up. Visible portion right here. Infrared, it allows us basically body heat, which we all emit. Radio waves. Okay, here's just an infrared image right here. Basically, it's a camera that picks up the amount of infrared radiation coming off your body, or the different levels of it, and then uses computers to basically assign a color to the infrared energy coming off you, so you can get images like this. I just briefly want to go back to our reference table. Okay, so when we go back to the reference table here, so we have small wavelengths and we have increasing wavelengths on the right-hand side. Also, besides being small wavelength, these are high energy. Okay, over here, long wavelengths is going to be low energy. Okay, so it's just something also to remember. And this goes, so ultraviolet or UV rays, which we commonly associate with skin cancer and stuff like that, have relatively high energy, which would make sense. That's why we use sunblock to block out UV rays, or even sunglasses have a rating for the amount of UV radiation and the type of UV radiation they can block out, because the UV has got a small wavelength or high energy. Infrared, long wave, low energy, and radio waves, which are passing through you right now. Anyone that has a cell phone next to them is experiencing a small amount of radiation coming off of it in the form of radio waves. That's how they're able to communicate to the cell phone towers. Radio, if it's on near you, those radio waves are going through your body right now, passing for the most part harmlessly through, so you don't need to worry about them because they have low energy. Okay, X-rays on the exact opposite end. Okay, small wavelength, high energy. This is why you need to wear those lead vests when you go to get X-rays taken at the dentist. They'll put that lead vest over you to kind of take in those, to block that high energy from going into you. Okay, moving back. Okay, here's the visible portion of the spectrum again. These are definitely, you should probably know them, but once again, they're in our reference table. Okay, Roy G. Biv, red, orange, yellow, green, blue, indigo, which is right around here, and violet. Okay, and we can see the long wave associated with the red over here, short wave with blue and violet. Okay, and once again, it's in the reference table, page 14. White light, when passed through a prism, will refract out into its component colors or a rainbow. Let's say red right here with its long wavelength, all the way through all the other ones, red, orange, yellow, green, blue. Okay, short wavelength, blue. And all the other colors basically will have Roy G. Biv right here. So prisms do that. White light is made up of all the colors of the rainbow. Okay, here's a rainbow right here. Actually, it looks like we got like a slight double rainbow right here, but you can see red, orange, yellow, green, blue, indigo, and violet here. And basically the water droplets in the air will act as small prisms. It refracts as it comes in, reflects as it goes out, and we see a rainbow. The position of a rainbow basically is depending on where the observer is. Okay, here's a prism again. Notice the white light coming in and then separating out into its component colors. Okay, and prisms can come in all shapes. Okay, so energy coming from the sun is going to be in the form of electromagnetic waves, which are a part of the electromagnetic spectrum. Remember, each electromagnetic wave or type of energy is going to be denoted by its wavelength, which is measured from crest to crest. Short wavelength, high energy. Long wavelength, low energy. And we can look at the different portions of the electromagnetic spectrum using our reference table on page 14.